Recording. It's exercise 1A. In year 9, we're essentially doing the year 10 course, and year 10 methods course is all about algebra. So you find that term 1, we're going to do a lot of things to do with solving, simplifying, equating. That's what we're going to be doing. The first part is chapter 1, which is to do with linear equations. So let's have a look. Review of algebra notes. Let's go. A term. Let me get the roll up just so that I can learn your names while I'm here too. Let's see here. Not this one. Let me get your names up. 9C. Keep the row. All right. Starting off with the first one. What is a term? It is a collection of, what is it? Can I please have? Let's go with Sean. It's a collection of what, do you think? Pronumerals, very good. Pronumerals or letters, whichever you want to call it. But it is pronumerals or letters. / letters. So a term is a collection of letters or pronumerals and or a number, often separated by, in this case, some of you may not know, this is just what I tell my year 8s, plus or a minus sign. Here's an example. You see, X, that's a term, that's a letter, plus 2X, that's a term. So right now, I'll call it 2Y, so that you can't simplify it. X plus 2y, that's one term, separated by a plus sign. 2y is your second term, and then I could have minus 1. That's a term. So one has letters, one has letter and a number, and one has just a number. But they're all separated by a plus or minus sign. So how many terms do I have in that expression? I have 3 terms. Okay? One of the most common mistakes that I often see with my year 8s when I first teach them is something like this. If I gave you, example 2, 2x plus 1 minus y divided by 3 times 4. How many terms are there? Hands up if you think you know. 3. What was your name again? Andrea believes there's 3, and I believe, are you counting 1, 2, 3 there? That's a good question. So that's another one that I want to say. Times 4, does that count? It's not 3. Anyone else want to have a go? Hands up. Yes? 5. So are you counting 1, 2, 3, 4, 5? Is that how you're doing it? And that is also not the answer. So not 4, not 5. Anyone else want to have a go? Is it maybe 2? I see what you're doing. Okay, so let me... so you're saying 1 and then 2? It's also not 2. Like I said, a common misconception. Sonny? Is it 3? So which one are you doing? You're doing 1, 2, 3. Is that what you're thinking? Probably not. 3 is also not the answer. It is 1. Now, let's have a think for a moment. Let's simplify this. You see, what I made it confusing for you was I purposely gave you 3 terms in the numerator. So you're right if you said 3. Yes, there are 3 terms in the numerator, but then because it's divided by 3, what if I change that? And I said 1 over 3 times 4. You would now say that's 1 term. But what's interesting is if I wrote this before and I said how many terms was here, 2y, you said there's only 1 term. So your question, was it Andrea before? Or someone said times 4, does that get included? You see, the times 4 doesn't make it a new term. Otherwise, this 2 times y should have been 2 terms. But 2y is actually still 1 term. That's why in my notes I said it's separated by a plus or a minus sign. So in this fraction that I gave to you, if you really think about it, what I did was I took a fraction, like 1/3, and I said times 4, but you can simplify that down to 4 over 3. So technically there's only 1 term. But how did I make it confusing for you, or what the typical confusion is that I purposely changed that 1 and I made it 2x minus 1 plus y, just to change the visual aspect of it, but the essence of it is still a number times another number still gives you a simplified number. Get me? So in the notes, why did I say often separated by a plus or minus sign? That's the reason why. Okay? So hopefully that clarifies your understanding. And the reason why it's important is because when you're solving equations, it will then change how you solve it. So here's an example. Year 8s, I often do this in a test to see how they understand about operations. So here's an example. You could have x plus 1 on 3 is equal to 4, and then solve that, right? Versus x over 3 plus 1 equals to 4. Both of them look very similar, but they are different. How many terms are there here? Have a think about what I just taught you. How many terms are here? 1. Yes, there's only 1, not 2. I know there's 2 in the numerator. Yes, you're right. But as a term, this is just a fraction, so it's only 1 term. How many terms are there over here? There's 2. Okay, so when you're solving for it, see the opposite of divide. This is divide 3. If you want to undo divide 3, you always do the opposite, right? What's the opposite of divide 3? Times 3. So what you learned back in year 7, you would have said times 3 on one side, but whatever you do to one side, you have to do to the other. So this is balancing, right? And then they get to this problem and they do the same thing. They're like, all right, well, that's a divide 3. So I times 3 on one side, I times 3 on the other side, and then 3's cancel out. X plus 1 is equal to 12. It's wrong. Why? Where have I gone wrong? Beautiful. You see, when you have 2 terms in one expression, it's like money. The way I explain it to my year 8s when I first teach them algebra is I say something like this. I say, if this is Mr. Tran, and that's you, and that's Albert, if let's say you tripled your income, and you want to keep it fair for everyone, you're like triple Mr. Tran's income, then you need to also triple Albert's income. True? Everyone has to get a fair, otherwise it's not the same. But then over here, you see, why is this okay to just multiply once? Is because this is one person. This is the money for one person. So if you triple this person's income, to keep it equivalent, this person's income has to also triple. So the importance of knowing how many terms there are in an expression is then to help you solve. Otherwise, the most common mistakes, this always happens, even at a year 12 level. And that tells me a lot. That's what I meant by question, method, answer. I can tell what your thinking is based on what you're able to do. Yeah, and so what you do tells me a lot on your theory, how well you truly understand what a term is and a coefficient, etc. Okay, so hopefully I clarified for you one of the sort of key terminologies you learned back in year 7. Let's go to coefficient now. Coefficient is the factor of what to a pronumeral? No idea? That's okay, because I'm obviously the one who wrote this note. So it's actually is the factor multiplying. The reason why I want to emphasize that is because most teachers, when they first teach coefficient to juniors, they'll say something like, it's the number in front of, right? But it's not the number in front of, because if it's the number in front of y, what's actually happening between 2 and y is that you're doing a factor of 2. You're multiplying it. You're doubling whatever y is. So teaching you to understand that a coefficient really is just talking about the factor in front of a variable that you don't know. So it's a number that you don't know. So y is what I don't know. But if I put a number in front of it, that is my coefficient. That's what it means. Yeah? Expression is a collection of... Anyone want to have a go? Hands up. Yes, it's a collection of terms. So what I wrote up here is an expression. X plus 2y minus 1 doesn't give you an answer. It's just an expression. I'm just expressing myself. I could say that, I don't know, let's say Jaden has $10 in his pockets and Mr. Tran has whatever Jaden has plus 10. That's an expression. I'm expressing myself. I actually don't know how much Jaden has in his pocket, but whatever he has, I will have $10 more. That's an expression. Yeah? What's the difference? Terms such as, what's this? Often associated with command terms such as, anyone know? So when we're talking about expressions in your textbook, you've done this since year 7, 8, and now you're doing it in 9. What's the command term? Command terms like evaluate, simplify, solve, what's another one? Factorize, expand. What's the common command term that associates with an expression? Anyone know? Hands up. It can be the operations, that's true. Looking a bit further than that. Very good. Simplify. And the reason why I'm highlighting this to you is because I get it with my year 10s and my year 11s. The question says evaluate or solve, and then they simplify. So it tells me that they don't even know what simplify means. Because in year 12, if you don't do exactly what the examiners ask, you lose a mark. So if they say factorize, you factorize. If they say simplify, you simplify. If they didn't ask you to solve, even if you simplified and then solve, they don't care that process. You answered them wrong. So you have to know when is it a solve and when is it a simplify. Simplify is like this expression. X plus X plus X plus X. No one wants to write that. That takes too long. So we simplify this process. X plus X plus X plus X can be rewritten as 4X. Who wouldn't want to write that? I'd rather write 4X than write X plus X plus X plus X. That's why it's called simplifying. Versus equation. See, equation must have an equal sign. Very good. It has to have an equal sign, and it's often associated with which command term then? Solve. Perfect. So when you see solve, you should be expecting an equal sign somewhere. If you don't see an equal sign and you're trying to solve, which happens at my year 11 level, I swear, I'm going to have probably a quiz with my year 11s soon. When they do, and I see it, I'll take a photo and I'll show you guys what I mean. It'll be something like, I'll give them x squared plus 2x. The question clearly says factorize or simplify, whatever it is. And then, this is what they do. They will then go, somehow equals 0 comes out of nowhere. And they're like, yeah, all right. Now I can do this, and therefore x equals 0, and x equals -2. And I'm like, that's fantastic. But if it was a year 12 exam, you get 0. Doesn't matter how much work you did, you didn't answer the question. Because it means that you don't know what you're doing. It's like if I asked an engineer to build a bridge, and they built me a car. Right? It doesn't make sense. You're not going to pay that engineer. Right? So, same idea here, just knowing the difference between simplifying and solving. So I know that's a lot of what I just described was year 7 content, but I think understanding it, truly understanding what they are, gives you a better understanding of what you're doing. Okay? Let's do some examples now. All right? So down here, I wrote an example, and I usually like to do it visually for those who don't like so much text. This is an expression. Expression. That's also an expression. Together, this is an equation. And the individual parts is what you will see. This is one term. This is one term. This is also one term, but there's a special name for this in year 7. Do you remember? What's a term where it's just the number by itself? What is it called? Constant term. Beautiful. Because the number doesn't change. It's constant. Whereas an x, we don't know what an x is. It could be anything. So hence, a term could be anything, whereas constant term implies that it's the one number. And then on the right-hand side, now that you understand what I was saying, or partly understand, it might take some time to digest. How many terms are there on the right-hand side of the equation? 1. Beautiful. Because it's all times. It's 9 times a squared times b cubed times 2 times c. Therefore, it's just 1. Because when you times them all, eventually it just becomes one number. Right? So that's why that's 1 term. So in a visual aspect, if you didn't understand everything I was just saying before, this encapsulates what I was trying to say. Okay? And remember, if I'm going too fast, all these notes are on OneNote, so you can always refer back to it, or you can watch this video again. But it's just to highlight what those different terms are. At year 9 level, they're going to assume that you already know all of this, so they're just going to jump right into simplifying the problems. Okay, so here we go. But the reason why I explain it is because I hope when you start solving later on, you don't make those mistakes I just explained, because if you can count the number of terms, then you know how many you have to do a factor of. Let's do the first one over here. Example 1, simplify the following expressions shown below. So this is a very long expression to write. We're trying to simplify. We're trying to make it smaller so that we don't have to write so much of it. So let's write. Now the only way to simplify, especially when you're looking at each term, how many terms does this expression have? Can I please have? Let's see who's the first person I see on this list. I've got Mira. Mira. How many terms do you see? Close. It is almost 3. This is 1. separated by a plus or minus sign, so this is 1. Here's a minus sign, so that's 2. Here's another plus sign, so that's 3. And then you've got your last one here. There's actually 4 terms. Now, out of these 4 terms, in order to add or simplify, to collect them, you're going to find ones that are similar. They have to be the same, right? They have to be the same terms. Now, which terms are the same? Can I please have, yes, what was your name? Sanvi. Ah, so why is 3xy and xy the same? I mean, they do look the same letters. Is that the reason why we know it's the same? Oh, good. So you're questioning that. Because if it's meant to look the same, then why are these two the same? I mean, they don't look the same. Yx squared and x squared y doesn't look the same, but yet they are the same terms. What's the answer, Sandy? Very good. Remember that times thing that I was talking about, separating by a plus or minus sign? You see x squared, sorry, I'll do the coloring. X squared y means x squared times y. Yx squared means y times x squared. The thing we know about multiplication is it doesn't matter about the order. You can do 2 times 3, which is 6, or you can do 3 times 2, it's still 6. So when it comes to letters, it's the same thing. It doesn't matter about the order. What it matters is whether the actual letters are there. So that's what Sammy was saying, that they both have an x squared and they both have a single y. So hence, they are the same term. It's almost like saying in groups, if I said, I'm trying to remember names again, Nishi and Cassidy. You see, Nishi is sitting here, Cassidy is sitting here, that's one group. But if the next lesson, Cassidy sits here, Nishi sits here, it doesn't mean they're in a different group. They are still the same group, they're just in a different order, right? So same thing with terms. Terms is the group. Doesn't matter about the order, yeah? So now we're adding them together. We're saying, all right, so we know which ones are similar. You've got 3xy minus xy. Those two are the same groups. And then you've got plus 4x squared y, which is the same as 2yx squared, but I'm going to rewrite that so they're the same. Now, which order should you write it? When you write your terms, write it alphabetical or alphanumeric is what they say. And that just basically means write in alphabetical order. Okay, so if it's x squared y or yx squared, just rearrange it to make it x squared y. Let's answer it. I've got 3 of these xy's. I'm minusing this xy. How many xy's do I have left? Can I please have? Let's go, Sahaj. What's 3xy minus xy? 2xy. So even though we don't write a number in front of it, realize this is just one group of xy. If it helps you, write the number 1 in front of it to remind you. So this is now 2xy plus, what is 4x squared y plus 2x squared y? Can I please have, who's the next person? Joanne? Do I have a Joanne? Yep. Beautiful. That's called simplifying. So I'd rather write this last line than I would for the first line. Notice that I'm implicitly also doing another thing in my lessons. See how I lay it out? Question, method, answer. It's a vertical layout. What I don't want to see in your homework is that you wrote this line here and then you wrote this line here. I know save space in your exercise book, but that is wrong. Okay, that is not the approach. We do it exactly like coding. When we write a code, it's in vertical lines. Each time you do a new line, it's a new entry. Okay, so practice starting to write vertically. If it helps you, fold your page in half so that you're forced to write it vertically rather than going horizontally. Okay? Otherwise, at year 12 level, you can get penalized for that as well. All right, here we go. Next one, B. Let's have a look at B. Negative 4AB divided by 8A. This one, what can we simplify? What are some terms that we can simplify at the moment? Can I please have, yes? Andrea? Yes. We can simplify A's. A divided by A is equal to what? 1, good. Sometimes students tell me it's 0 because they're used to doing this. So some tutors will teach them to just cross them off if it's top and bottom. The problem with that is when you get to a typical question, say in your Melbourne High exams, if you do that, there was a problem where it did this. And then it asked you A, B, C, or D. There's a problem to this if the students did this. Okay, so that becomes x on 1 and the answer is just x. What's the problem? Actually, I should change that to an equation. If they said solve for x, a lot of students will tell me that the answer for x is x equals 1. There's actually two answers to this. Where do you think the mistake had already occurred?
At the start, x squared is x times x. So just cross that one.
Very good. And that still gives you x left over. And then that will be x equals 1. But that only gives you one answer. How would I get 2? Well, there's not a... Oh, I see what you're thinking. But that's not exactly there. Maybe I'm pushing a bit too much here. Anyone actually know what you can't do in this equation in the first step? Why can't I just go that, or what Yuna just said there? Why can't I do x divided by x? What's the problem? You could. The mistake or the problem is, do we know what x is? No. There's an assumption here that you can divide that x number. What if x was 0, hypothetically? Now, can you do 0 divided by 0? Try it on your calculator if you want at some point. You can't divide 0. You can try 0 divided by 0 on your calculator and it will be undefined because we cannot divide by nothing. Okay? And so that's one of the things that they test on the Melbourne High selective exam that I've seen, or they've done it in a year 12 multiple choice question. The first step right there, you can't just divide. So same thing here, when students do it, they don't realize a divided by a is actually 1, and it gives you the answer. I'm just going to rub all this out so you don't get confused. But that gives you negative 4 times 1 times b on the top, and on the bottom it's 8 times 1. That's what you're actually doing. But because timesing 1 doesn't change anything, that's why your teachers normally just say, cross it off. I don't like the idea of crossing off, because if you get into that habit, that's why they test you at the year 12 exams. Yeah? So just knowing that yes, you can divide them, but it is a 1, not a 0. And then what's the next thing that I can simplify as well? So the 1s can be divided by each other. A divided by a is 1. What else can I simplify? You know? 4 and 8. 4 and 8 is the same thing as writing half, so you can rewrite your answer as negative 1 over 2 times the 1 times the b, and we know that the answer is then negative b on 2. Okay, so I'm just following the order. Negative 4 times 1 is negative 4 times b is negative 4b, but the 4 and the 8 can be simplified, so hence negative 1b on 2. Okay, let's go. Next one, I'm going to pick up the pace a bit, just so that we're not spending too much time on the basics here. This one, C, I purposely wrote this one because I normally see mistakes with my 10s and 11s. I want to see if you guys are going to pick it up. So I'm going to write the wrong thing to do. See if you can pick up where I go wrong. So don't copy this yet. I'm going to do 2 times x, which is 2x. 2 times 3, which is 6. Negative 3 times 2x is x. And then I've got 3 times the negative 1, which is, what's that? Negative 3. Simplifying that, 2x take away 2x cancels out. 6 take away 3 is 3. Where have I gone wrong? Beautiful. Common mistake that a lot of students do is they take the number out the front. The first one never goes wrong because students take the 2 times x, 2 times 3. But it's the next line. It's not 3, it's negative 3. Negative 3 times 2x is, sorry, I did multiple things wrong. Negative 6x, and then negative 3 times negative 1 is positive 3. This one is where the mistake comes. Okay, so make sure the number, the coefficient, okay, so the coefficient is the factor, the signs are included. You're used to using positive numbers, make sure the negatives is not one that you make a mistake on. Okay, so it's negative 3 times 2x, it's negative 6x, and negative 3 times negative 1 gives you positive 3, not negative 3. Then in that case, 2x minus 6x is, what's that, negative 4x, and then 6 plus 3 is positive 9. Okay? Next one, factorize. Factorize is the opposite of expanding. So we're now, instead of expanding means timesing, which is what we did. We expanded by multiplying the factor. Then factorizing is dividing. So if you're dividing, you need to figure out, well, what's the highest common factor between the two terms? We got 3x squared and 9x. What's a common term can I please have? Let's go with Emma. What's common about 3x squared and 9x?
3.
Yes, they both have a 3. I'm just going to write here. Highest common factor is a 3. And there's also one more thing. Anyone know? X as well. Okay, so if you break it apart, you can see it. So if I break out 3 in front of x squared means times. What are you multiplying to? X squared, but x squared is the same thing as saying x times x. These are called factors. Yeah, just like 12. If I said, what's the factors of 12? You would say 12 is 4 times 3, but it also could have been 6 times 2, but it also could have been 1 times the 12. That's why when we say, what's the factors of 12? You say 1, 6, 2, 3, 4, and 12. So it has to be timesing. So here, they're all timesing to each other. So there are 2 x's as a factor, and there's a factor of 3. Then you break this one in the same concept. 9 can be broken up into 9 times x, but 9 can be broken up into 3 times 3. So when you highlight what's common about the 2 terms, well, they both have a 3, just one 3, and they both have 1x. You see that? That's why we say highest common factor is 3x. What's left over? Well, I've got this factor left over, which is an x. What's left over here? Well, I still have a 3. That's why when you factorize it, 3x times x gives you 3x squared, and 3x times the 3 gives you the 9x. That's the logic, because it's your leftover factors. Okay? All right, that's the first page. So far, so good? All right. Can I get a show, just so I know the pace here? Hands up if you feel that this is going a bit slow. Okay, 1, 2, 3, okay. Hands up if you'd like me to go a bit faster. Well, the same group. Hands up if you like this pace. So it's a bit of both. That's all right. I'll do a bit of both either way. What's the difference between evaluate and simplify? Evaluate is when you substitute and get a number. So just right here, sub and number. Simplify is expression. So in this question here, they say evaluate b squared minus 3a cubed c to the power of negative 4. Let's see how many, I want you guys to have a go with this one first, and then let's see how many of you get it right. I purposely put a lot of negatives in there because I wanted to see how many of you are going to make this mistake. So let's go. B squared minus 3a cubed c to the power of negative 4. What if a was negative 2? B is negative 3. And C is negative 1. Have a go. I'm going to pause the video for a bit. Let's see what you guys got. So I like the layout. Question, method, answer. So I've put out my problem. Here we go. B is negative 3, so I'll write negative 3 squared. Notice I'm using the brackets. Minus 3 times A, which is negative 2 cubed. C, which is negative 1 to the power of negative 4. Okay, and then I do it individually. Negative 3 squared, what is that? Can I please have Michelle? 9, very good. Minus, now let's work this one out. It's 3 times, what's negative 2 cubed? Can I please have, let's go with Sunny. Negative 2 cubed. Negative 8, very good, because it's negative 2 times negative 2 times negative 2. Need even number of negatives to make it a positive, so clearly that's going to be a negative 8. And then what is negative 1 to the power of negative 4 equal to? Can I please have Toby? That's correct. The answer is 1. And for those who don't know, especially with negative powers, just know that you could rewrite it as negative 1 to the power of negative 4 is the same thing as writing 1 over negative 1 to the power of 4. But the point is 1 to the power of any even power is always going to be a positive 1. Okay, so it's whether it's even power or odd power. So here, negative 1 to the power of 4 will end up being negative 1 times negative 1 times negative 1 times negative 1, which we know that's going to give you a positive 1 there. Okay, so that's how we know it's 1. So if you put it all together, it should be 9. Negative 3 times negative 8 is positive 24. 24 times 1 is positive 24. 9 plus 24. Hands up if you got this answer. Hands up if you made a mistake on the negative 1. Oh, no one did. Okay. Hands up if you made a mistake on the negative 2. And then hands up if you made a mistake because of this negative at the front. Okay, cool. Just some things to look out while you're solving the problems. Next one, and the last one for today. This is an enrichment question from your textbook. All right, we ready? Eyes and ears towards the board. Here we go. So this is an enrichment question. Some of you will get to it. Some of you may not get to it. Enrichment question 12b. So sometimes I'll try to add in and see if I have time to go through it as well, for those who do want to attempt it later on. But here it says, thanks team. Still waiting. Find expressions in the simplest form for the perimeter and the area of these shapes. Your answers may contain pi. For example, for pi, do not use decimals. Means don't use a calculator. Okay. Now, one of the first things you should realize is this is a quarter of a circle, so it means that you need to know how to find some circle formulas. There are two. There's one that is c equals 2 pi r, and there's the other one which is a is equal to pi r squared. Which one are we going to use here? C, very good. Circumference, because in a circle, circumference relates to the distance outside of a circle. So we're interested in that quarter part. So hence we use C. We're not looking for the area. It's different. Okay. So in this case, we're going to be using C for the perimeter. So this part here is then C is equal to 2 pi times R. But then because it's a quarter of a circle or 90 degrees, it's 90 out of 360, which is a quarter, right? 2 pi times, what's my radius? Very good. This is my side. That's the radius on the side there. So hence it's x times a quarter. But we can simplify the fraction here. We can see that 2 and the 4 can be simplified to 1 over 2. So really, it should be pi x over 2. Don't change it to decimals. Instead, keep it in pies, right? So now I've got the circumference. I know this distance right here, from here to here, is pi x on 2. Okay? To find the perimeter, we know we have to add all the sides together. So here we already know, or we can figure that one out. We know this side is x, and we know this little length here is 2x minus 3. So let's put it together. The perimeter should equal to x plus, how would I find this distance up here? What's the full distance of the length of this rectangle? Is she? Very good. So don't forget, on the bottom here, this is 2x minus 3. But then we also know this extra length was also x, because the radius is the same. For that quarter circle, the radius is the same for the vertical line and the horizontal line. So if that's x there, then together it's 2x minus 3 plus an extra x. So here we go. 2x minus 3 plus an extra x. That gives me the length on the top. I already found out the curve. The circle curve was pi x on 2. And then finally, the part that I was highlighting in yellow, 2x minus 3. Obviously, you don't leave your answer here. You've got to then simplify the expression. But this is an example of an enrichment question. Okay, so it's not hard, but it does work with more letters, more fractions, more negatives, and you've got to get used to working that long expression. So that's what it's practicing. Okay, so for those who are strong with their algebra and very comfortable with fractions and negatives, this is a good place to get to as well. Okay, so here we go. This would then give you, what's that? X plus 2x plus x is 3x minus 3 plus pi x on 2 plus 2x minus 3. We can say x plus 3x is 4x plus 2x is 6x. That gives you 6x. Negative 3 minus 3. Negative 3 minus 3 is minus 6. And then you've got plus pi x on 2. Now at year 12 level, they would want you to combine that all as one term. How many terms do I currently have right now? 3. So when they say they want one term, and some years they penalize here, some years they don't. But when they're really tight on the ranking, they will then penalize here. So because they say simplified expression, this should all be done in one term. So then this test is whether you know your fractions here. 6x writing as a fraction is 6x on 1. Negative 6 you can write as on 1. So if it's in halves right now, because it's pi x on 2, you're going to make sure to times them all by 2 to then change it to 12x on 2 minus 12 on 2 plus pi x on 2. So what should your final combined answer be? It would then be 12x plus pi x minus 12 all over 2. This is considered one term. And if I had to be nitpicky at a year 12 level, I wouldn't be happy with my students leaving their answer like this as well. What do you think we can do to simplify it just a bit further? I'm really pushing you guys here, I know. Anyone know? Add 12x and pi x, which you can't add them because they're not the same numbers, 12 plus pi, but you can factorize. They both have an x, so at year 12 level, you would take out the x, 12 plus pi minus 12, all over 2. And that will be considered 1 mark. Okay? Yeah. But, you've got many years till you get there. So some years they will penalize you if you don't do it to this degree. Some years they'll not penalize you and they're okay with this. But that's for later on. Okay? All right, I'm going to stop there. Otherwise, it's too much of my time explaining, but that's an example. Okay, so I hope you learned something. I'm going to leave it there. I'm going to stop the video.